Good morning, dear students. In today's lecture, we will talk about the last type of chemical reaction. That is your double displacement reaction. We have covered combination reaction or addition reaction. Then we have seen decomposition reaction. Then we have completed displacement reaction, and at last the fourth type is your double displacement reaction. Now the general representation, then we will define double displacement reaction. So suppose there are two solutions of ionic compound. Solution first is of AB and solution B is of C. Imaginary compounds, ionic compounds. A is your cation and B is your anion. According to rule, first we write cation, then we write anion. So similarly in CD, C will be your cation and D will be your anion. So when we mix the solutions of two ionic compounds, then what will happen? A will combine with anion of second compound. Cation of first compound will combine with anion of second compound. Similarly, cation of second compound will combine with anion of first compound, as a result of which we will obtain two new compounds. So A plus with D minus gives you A plus D minus plus C plus of second compound with B minus of first gives you C plus and B minus. So what is happening in this reaction? Exchange of opposite ions takes place in between the two different solutions. So how we can define double displacement reaction? A chemical reaction in which reactant reacts by exchange of ions of the solutions of two ionic compounds to get two new more compounds. So simple exchange of opposite ions is taking place in this chemical reaction. So this is your double displacement reaction. Displacement reaction taking place two times. So it is the general representation of double displacement reaction. Let us take one example. HCl, it's your hydrochloric acid made to react with sodium hydroxide, a basic compound. Acids form H plus ion while bases forms OH minus ion. So here H will be your positive ion, Cl will be your negative ion, Na will be your positive ion and OH will be your negative ion. Now exchange of opposite ion will take place between the ionic solutions, two ionic solutions. So H plus with OH minus forms H2O here, that is your liquid, it's your pure state, and Na plus with the Cl minus forms NaCl, it is a water soluble compound, so you will get a aqueous solution of sodium chloride. So hydrochloric acid is made to react with sodium hydroxide, a basic compound, to form salt, NaCl and water. It is a type of double displacement reaction, and in double displacement it is a type of neutralization reaction. So what are neutralization reactions? When acids are made to react with bases, then we always get salt and water. The reaction is called neutralization reaction because one of the neutral compound, that is water, is formed in this chemical reaction. So it is your neutralization reaction belongs to double displacement. Now we have one more chemical reaction in double displacement type, that is called precipitation reaction. Now what happens in precipitation reaction? Again we will be taking two ionic solutions. We'll mix both the ionic solutions. Exchange of opposite ions will take place, but after the reaction one of the compound form, definitely you will get two compounds. Out of two compounds, one compound will be water insoluble. So what happens to that water insoluble compound? That insoluble compound will get deposited at the bottom of the beaker or the bottom of the test tube or the bottom of the container. That insoluble part is called precipitate. The insoluble solid formed after the chemical reaction is called precipitate. So if you are getting an insoluble compound in the form of precipitate during a double displacement reaction, then that double displacement reaction is called precipitation reaction. So example, we can take example where sodium sulfate is made to react with barium chloride. Sodium sulfate, it is a white color solid and soluble in water. Barium chloride, it is a white color solid and soluble in compound, so it's soluble in water. So we will get an aqueous solution. AQ stands for aqueous solution. Aqueous solution means solvent is your water. A solute is added to water, then we get aqueous solution, represents AQ, aqueous. So sodium sulfate, soluble in water. Barium chloride is also soluble in water. Now sodium ion plus ion, sulfate is your minus, anion part here. Barium is your positive part, Cl is your negative part. What happens in the reaction? Exchange of opposite ion will take place. So Na plus will combine with Cl minus to form sodium chloride, that is your NaCl. You know it very well that common salt, sodium chloride or table salt, is highly soluble in water. So what we will get? We will get the aqueous solution of sodium chloride. But the second compound form, that is Ba with sulfate, gives you barium sulfate, BaSO4. It is a white color solid and insoluble in water. So BaCl2 will be deposited in the form of solid at the bottom of the container or beaker or test tube. So barium sulfate forms the precipitate. So it is an example of precipitation reaction. Remember one thing, all precipitation reactions are double displacement reaction, but all double displacement reactions are not precipitation reaction. Example we have of neutralization reaction. So this is about double displacement reaction. Remember, whenever we are writing a complete chemical equation, then we have to represent their physical state also. Like AQ is the solution form, H2O is your pure liquid, so liquid air. If you obtain any gaseous compound, then gaseous compound can be written as in bracket gas, or we can write up arrow like H2 up arrow means H2 is a gas. Similarly, barium sulfide here is a solid, so I have written solid, or I can also write, represent it in this way, that's your down arrow means it is your precipitate. So in this manner a complete chemical equation is written, means we have to specify the physical state of the compound also. So that's all in double displacement reaction. In our next lecture we will talk about exothermic reaction, endothermic reaction, reduction reaction and oxidation reaction. So that's all for today. Thank you. Have a good day.